Motor jogging controls. Where are we going to use motor jogging controls? Well, primarily we see them in instances of crane hoists, and that's because sometimes you only want the crane hoist to lift a very small fraction of vertical distance. And to accomplish that, you need to energize the motor for an extremely short amount of time. With our typical form of motor control, this can be a challenge. So this would be standard motor control here, where we have a start push button and a stop push button. If we want to turn the motor on, we press the start push button, which energizes the coil, but engages the holding contact. If we release it, the motor stays energized. If we want to then turn off the motor, we have to press the stop push button. So consider if you needed a crane hoist to lift only an inch. This would require a motor, the hoist motor, to run for only a quarter of a second. How easy would this be with a typical motor control setup? Well, you kind of need to have both your fingers hovering over the start and the stop push button, because as soon as you press the start push button, you would then, a quarter of a second later, need to press the stop push button. And it would sort of look like this. Energize, quick, turn it off. And hopefully we didn't run the motor for too long. So this type of control has its downsides. So jogging is momentary motor control for precise movement, and typically this function is used in addition to standard low voltage protection control. So here's our first jogging circuit. It's a normally closed, normally open push button, and it's labeled as the jog push button. And the process or the purpose in using this would be when you press it down, it makes a connection here, bypassing the start push button, energizing the motor through the coil. And then when you release it, it breaks the circuit. Now, this is considered to be a dangerous or not the best way of doing things, because you're really dependent on this contact opening before the push button goes back to its normal closed position up here. So this is dangerous because if you were hoping that it was going to jog, when you release the push button, you may inadvertently connect this before the contact had opened and then have a full holding motor connection, which would mean the motor continues to run. So this isn't really a form of control that we would want to replicate. Instead, we use a arrangement like this. This is one of two different types of jogging controls that are actually practiced out in the field. So this is using a two-position maintained switch. In one position, it says jog. In the other position, it says run. So we have a two-position switch, but then we only have one start push button. And this start push button will be used for both normal operation and jogging. So let's see how that works. So here we go. We've got it in jog position. We're going to press the start push button down, and notice it's going to energize the coil. The contact's going to close, but because we have a big air gap down here, it's not going to complete the circuit. And so when I release the push button, the motor turns off. Again, press it down, energize the motor, and release, motor turns off. So I can control precisely how long the motor runs for. If instead we change that selector switch to run, now when I push the start push button down, again, we have current flowing to the coil, but that holding contact will close. Holding contact closing means I now have a holding path and I have low voltage protection, and I would have to press the stop push button in order to turn off the circuit. Another type of jogging circuit is this one, and that's where we use a control relay and a second normally open push button. So now I have a start push button and a jog push button. Let's see how this one works. I press the start push button. I energize CR relay. And as soon as CR relay is energized, its contacts change state. When those contacts change state, current is now going to flow to M coil, which is actually the coil that controls the motor starter. At this time, the motor turns on, but also the holding contact for M coil closes. And in doing that, it allows current to flow through the bottom holding portion of the circuit. Now, when I release my finger from that start push button, the circuit remains energized and the motor runs as would be normally expected. If I want to turn off the motor, I would then have to press the stop push button. Okay, so how would the jog push button work? Well, if I press the jog push button down, that will energize the M coil without the CR coil getting energized. And so what that means is that even though the holding contact for the M coil is closed, this contact is open, so there is no holding path. When I release the jogging push button, the circuit turns off. And so again, I can control how quickly I energize the motor for. Jogging is a pretty common application in electric motor control, and at times you'll see it mostly in the crane and hoist areas.